Hello and welcome to the fourth lesson in Unit 5. Today we're looking at properties of exponential functions. So what I want to do today is I want you to be able to explain or identify the properties of an exponential function. Then I want you to be able to tell me domain, range, growth, and decay in real-world applications. So it's a two-part lesson. First part I'm talking about just the properties. I'm going to flip over to Desmos for a second. We're going to play with Desmos and see what an exponential function looks like. So an exponential is when the variable x is in the exponent. So y equals, and I'm just going to pick base 2 or 2 to the exponent x. And here's the graph that results. So this is a typical shape of an exponential function. So you'll notice that it doesn't go below the x-axis, it stays above the x-axis. We see that it crosses the point 0, 1, and we can try a bunch of variations here to see does that ever change. So instead of a base 2, let's go with base 3, still the same, base 4, base 5, always passes through 0, 1, okay? So it does not matter what the base is, it's always going to pass through this point right here. Alright, another thing I want you to look at, I'm going to go back to base 2. Now I'm going to add a new function. Alright, or a new graph. And I'm going to go back to that y equals, I'll go 5 to the exponent x this time. And look at the difference between the two when you compare them. Alright, so I'll play with this one. So let's go back, I'm going to make it a 2. Okay, so now they're the exact same. If I go 3, look what happens. 4, 5. And as we get the base, as the base gets larger, we see that it becomes steeper and steeper. So the larger the base, the steeper or the quicker that graph increases. So here's your 2 to the x line, and it's going to just keep getting closer and closer to that y-axis. All right. If I was to get rid of that for a second, if I was able to zoom in and zoom out here, look at how the graph acts on the x-axis. So as you can see, it never ever crosses it. It keeps going forever and ever. All right, what we call that, we call the x-axis an asymptote, and I'll talk about that, or I'll put that in our note in one sec once I finish. I have one more thing I wanted to show you. Oops, see if I can bring this back in. All right, so oops, I want to expand that out. So the last thing I want to show you is what happens if that exponent becomes a negative. So I'm back in that base function, and watch this. If I make the exponent negative, it changes the graph. So it goes the opposite direction. So instead of increasing, it's now decreasing. So we have two functions. It's increasing if the exponent is positive, decreasing if it is negative. So what I've done, I've taken a couple screen captures. What I need you to do in your note in the space provided here, I need you to sketch. All right, sketch that that note, and I've got a bit of a phantom circle here. I need you to sketch those two graphs right there. All right, and on the one here, we're going to write y equals 2 to the positive x, and over here, this is y equals 2 to the negative x. All right, so we need those general shapes because we're going to list the properties here. So the first property, okay, is that all base exponentials and exponentials go through the point 0, 1. So they all have the same y-intercept, and that's 0, 1. The second one is we can put any x value in here. It does not matter. So our domain is x is an element of real numbers. And our range, and this is for a base graph, never ever goes below the x-axis. So y is an element of real numbers. Y is always bigger than 0. Third point, as the base increases, so as our base gets larger and larger, the function increases faster. All right, so as we get our base bigger and bigger, the function increases faster and faster. And the fourth property, talked about the x-axis. The x-axis is what we call an asymptote. An asymptote is a line that a graph will never, ever, ever cross, and it's spelled really funny. So there's asymptote for you. So the x-axis is an asymptote. Graph will never cross the x-axis. So graph will never cross the x-axis. Okay, so those are the base properties I want you to take from this. Oh, one more, the fifth one. So it's going to be like that. So the fifth one, hey, if x, actually if, let's go with if exponent is positive, it's what we call increasing. Okay, so this is a positive base right here, so it's increasing. If we go with a negative base, I'm going to have to shrink this in just to get it in for me. Okay, if exponent is negative, it is a decreasing function. All right. So those are the 5 properties that I need you to be aware of or be able to work with when we get tested or I ask questions about that. So anyway, down below here. So that's what I'm going to focus on if I can. Here we go. So applications of the general equation. All right. So the applications of the general equation are like this. So here's our general equation. Y equals ab to the exponent x. So that means that our a value is our initial amount. Or starting value. And b is our base. And x is our, it could be whatever, time. Time is the normal one there for the most part, but I'll put etc. just in case of the cases that I'm not coming to mind right away. All right, so that's your base equation, the one we're going to be working with. And what I want you to be aware of as well, for our base, so for b, for our examples today, if we have a percent increase, so for b with a percent increase or decrease, increase, decrease, all right, you got to remember this is like taxes. So if it is a 13% increase, our base will be 1.13. If we have a 13% decrease, then our base is going to be 100% minus their 13, so it's going to be 0.87, for example. All right. So on to some examples. I only have 2 on the next page. So if you flip over to the next page here, the first one up here, it says that the town of Mitchell has 2,500 people. So this is an initial value. This is going to be our A value, the starting value. The population is growing, so that means that 100% of the population will be here next year, 7% more will be here the year after, so 107% or 1.07. All right, that is our B value. And that is, every 3 years. So every 3 years is going to be our exponent here, and I'll talk about that, how that works right now. So for A part, we have our base equation is y equals a b to the x. So y equals, A I already said is 2,500. B is going to be 1.07, the 7% growth. And here's the tricky part. Because it's every 3 years, this is when the growth period occurs. So our exponent is going to be a fraction. It's going to be how much time has passed divided by 3. Okay, so this is our 7% period. So that 7% period, if it was 1 year, the denominator would be a 1. If it's 2 years, the denominator is 2, but every 3 years, so that means that our denominator here is 3. Okay, so the next question then, B, 10 years and 25 years. So y equals 2500, 1.07 to the exponent 10 divided by 3. And punch that into a calculator. And y equals 2500, 1.07, 25 divided by 3. Alright, so those exponents that divide by 3 is the only really tricky thing you need to be concerned with as you go through here. And now it's just a matter of punching it through the calculator. So if I quickly do that, we find that 2500 times 1.07. Now use your exponent button on the calculator, the x, the y, to the exponent. I'm going to have to use brackets because it's a fraction. 10 divided by 3, closing bracket. So I get 31, and you can't use a decimal here because we're talking about people, so we're going to say 3,133 people. You can use whatever rounding direction you go is fine. It's 31, 30, what did I say, 33 people. Okay? 333 people. Alright. And then you can go ahead and use your calculator for the second example there, but it's just punching it into the calculator. Alright, the next question here is similar to this, to the first one there. It triples every 6 hours, so there's a ton of information in there. First of all, it does tell us our base, and rather than, I'm going to put this example onto the second video rather than me jamming it in here and not explaining it well. So I'll finish this one in the next video.